Hello and welcome to this series on writing a simple compiler using C#. In this first video we're going to start off by just writing an interpreter, and then in the future video we'll change that to generate some C# code, and then finally we'll change it to generate some IL code directly. Now we want quite a simple language to use, and the one we're going to use has just 8 commands, and its memory is an infinitely long tape. So the tape has an infinite number of cells, and each cell can contain a byte. And these are our 8 commands here. So we've got a greater than symbol, which moves our data pointer one position to the right on the tape. So this is indicating the cell we're currently reading. So when we see that symbol, we move along to the next cell. We've got a less than sign, which does the opposite. It moves the current data pointer one place to the left. We've got a plus sign, so that means whatever cell we're currently pointing out, we increment the value by 1. So in this example, that 0 can be replaced by a 1. And if we did a plus again, that would then become a 2, and so on. If we do a minus sign, we take 1 off that value, so that would go back to 0 in this case. Dot outputs whatever character is currently in that cell. So the cell will contain an ASCII code. So if we had the ASCII code for A and we saw the dot symbol, we'd print A on the screen. The opposite of that is comma, which populates the cell with the key press. So if you press B on the keyboard, it will populate it with the ASCII value of B. And then finally for loops, we've got square brackets. So if the value we're pointing at isn't a 0, then we skip a load of instructions onto the matching closing bracket. So if we look at an example program, which will make a bit more sense, so here's an example program here. So if we reach that and the cell we're currently pointing at isn't a 0, we go forward until we find its matching bracket, which is there in that case, because the brackets themselves can be nested. So that's its form of loops. We're going to call this bf.net, and it's a Turing Complete language. So it means it is possible, in theory at least, to write any program. However, it's not, as you can see here, it's not particularly easy to read, and it's actually quite hard to actually write any programs in it. So the first thing we're going to do is just write a simple program that reads in our instructions, and it walks along each instruction one at a time and executes that code. So when we're running it properly, we'll have a little loop where we can type it in the console, but for now we'll hard code it to make our development a bit easier. So we're going to need 3 things. We need a tape to represent our memory, and we need 2 pointers, one to the current location in the tape we're dealing at, so the data pointer, and another one to which instruction we're currently looking at. So let's create those now. So I have tape. So to start things off in this video, we're going to have the tape as something really simple. We're just going to have it as an array of bytes. And we're just going to say it's 10,000 bytes long. And then we need our data pointer. Because you can go left and right on the tape, and it's infinitely long, we're going to start with the data pointer just in the middle of the tape, so at position 5000. And we also need our instruction pointer, which is pointing at our first instruction, which is the plus. And we can keep looking at instructions until we reach the end until the instruction pointer gets to the end. So we want to say while the instruction pointer is less than the number of instructions we've got, which is its length. Okay, so then we know the current instruction is just the cell we're currently pointing. It's just the symbol in here we're currently pointing at, based on our instruction pointer. And now we can do a switch statement, because we've only got these 8 possible commands, and we can use a switch statement to execute the right code. So the first code we're going to do is the plus sign. So plus means we're going to increment the value by 1. As a character or a string. So we need to increment the value we're currently looking at in our tape by 1. So the value we're currently looking at, we'll write out in the data pointer. So that's the current value. We need to increment it by 1, and then we're going to write it back to that. Okay, so we've got a compiler error here because it's trying to convert this addition back to a byte, so we can just explicitly cast it for now. Then we have the opposite of that, which is subtract. So that handles those characters. So the next important one is the ability to be able to move our data pointer left and right. Probably should have done those first, in fact. So that's quite straightforward. That's just a question of decrementing the data pointer by 1. And to go right, incrementing it by 1. So that covers off these first 4 instructions. So the next one is to be able to output and read in a character. So we'll do the output first. Just a full stop. So the way we're going to output a character for now is we're just going to write it to the console. So that will just be output.write. Right, that. And then we need the character we want to output, which is the thing we're currently looking at on the tape. And we need to cast that to a character, a char. Then we've got the opposite, where we can read in a character using comma. So in this case, we're saying, no, not saying that, we're saying so we need to read a character, read a key. Yes, that gives us a character. And then we need to cast that to a write. So that does these two. So now we've got our loop. So if the current value is 0, then instead of going to the next command, we need to jump forward to the command after the matching bracket. So before we can do that, however, yeah, we probably should add some code to actually move the instruction pointer. So each time we execute a command at the moment, we move the instruction pointer forward by 1 place. Now, however, we need to say, well, if it is 0, we can show around in it. Okay, so if it's not 0, we just go forward as 1. Okay. So if it's not 0, we do what we normally do. Else, we have to go to the position after the next matching close. So to do that, we need to keep track of the number of open brackets we've got. So we've got 1 open bracket at the moment. Then while the number of open brackets is not equal to 0, then I think we need to move on 1 character Then we say if the next character if the next instruction is another open, then the number of open brackets we can increase by 1. Now, if it's a close, then we can decrease the number of open brackets we've got. So we've done that, so over on there, when we get to there, then we got down to 0, so we've found the final open bracket, and then we need to advance one more position, because you have to be the position after that. Okay, so we're doing that on either side of the loop, so we can take that out. In fact, we can swap that out. So if it's pointing to 0, we can go to the end of the loop. So we say we've got one open bracket, we keep going until we've got no open brackets, so we look at the next position. If it's another open bracket, we've got one more. If it's a closed bracket, we've got one less. Then we've either need to, so then once we've got to the final closed bracket, we need to go to the instruction afterwards. So that does that. That's that one. And then finally, if the data at the pointer is non-zero, then instead of moving the instruction forward to the next command, we jump back to the command after the matching open brackets. So it's the same idea, but backwards. So if it's not 0, and we move backwards 1, I think that's the same. So then when it's the command after the bracket, so we still go forward 1, otherwise we go forward normally. Right, I think that does it. Okay, so if we run our program now, we can see what happens. Let's just put a breakpoint. Exit. Breakpoint a bit earlier, I think. And hello world. So our program has successfully managed to interpret our instructions and print out our hello world. So we can now replace that by a bit more of a REPL. And so we just have a loop where we ask the user to enter their command, and if they've entered that site, obviously exit, we then run the program. So our program could read in a value, add 1 to it, and then print it out. So we put an A in, it prints out B. So that's worked. So we read in the A, we increased its value by 1, and then we printed it out, so it becomes a B. So that's working nicely. So in the next video, we will continue working on this, and we'll just look at a couple of ways we can optimize this, because we've made an assumption here about the size of the tape, and really we'd like to have some sort of tape that's going to grow automatically, because we don't know how much space we're going to need in that tape, and it's meant to be infinitely long. And secondly, we can look at this code here, because this code looks a bit nasty, because if you've got a very long program, then we're making quite a lot of effort looping going backwards and forwards for loops. Thank you for watching.